Now I know I usually start my videos off with a silly skit or something like that, but since this is a serious subject, I figured I'd jump right into the meat of it here. As makers, as inventors, as tinkerers, as handymen, or handywomen, or handy persons, we're going to be tempted at some point to jump in and start working on some high voltage equipment, similar to this guitar amplifier behind me. Now, as we know, high voltage is dangerous. It can send a current through your body, right through your heart, stop your heart, and you're dead. Some of these guitar amplifiers run somewhere around 400 to 500 volts. That's a lot. Some of the older ones even have something called a death capacitor. So you want to be very careful when you're working on these. So if you think you've hit a certain point where you think you know what you're doing, you understand what the dangers are, and you know what not to do, another piece of safety equipment you can use is called a current limiter. In this video I'm going to show you how to build one. This is my current limiter. It's a little fancy. I steampunked it up a bit. Basically you can build one of these for about 10 bucks. You can just use a plywood base here, some construction grade junction boxes, cheap cover. You don't need the cage over the top, computer cord from an old computer. You don't need the cage like this. I just thought it looked cool, so I put it on there. The current limiter, as its name implies, limits the electrical current moving through the wires. You plug one end of the current limiter into the wall, and you plug your piece of equipment into the front. Then if you happen to touch something to ground and you draw a bunch of current, rather than blowing a fuse or popping a breaker or something like that, this light bulb will turn on in here, and it'll dramatically reduce the amount of current running through the chassis of your equipment, and hopefully through you. This is a fairly easy project. It's probably about as easy as electronics get. If you watch this video and determine that this is beyond your capabilities, then don't mess with this, because you will get hurt. So these are parts we're going to need to build the current limiter. I kind of went a little high end here with some of the things. For instance, I used weatherproof junction boxes here, which is kind of like one of these here, but I just spray painted these black. Now, you don't need to go with something this heavy duty. You could easily go with something like this, but I wanted something that would look nice on my desk. Underneath here I have, this is just MDF, a 1/2 inch piece of MDF and a 3/4 inch piece of MDF that I routed out some shapes on and everything else, so it looks kind of pretty. And then this is a computer power cord. You may recognize that with the 3-prong. And this was just a white plastic base for a light bulb. This is a treble light enclosure, like a cage. It just happened to fit on there, and I found out at the hardware store that they fit almost perfectly, so I figured, well, I like the look of it. It'll look pretty neat, so I got that as well. Now you don't need to go that high end. Again, do whatever you want to do. But I figure if it's going to be sitting on my desk, I want something that's going to look nice. I also spray painted all of these black and cover them with rub and buff. Basically it's just a waxy thing that you put on there and the wax dries, and it gives it a nice metallic sheen, which is kind of cool. So this is very steampunky looking here. And you want to have an incandescent light bulb. You can't use an LED, you can't use the CFLs. It's got to be an incandescent. The higher wattage the better. This is the highest I could find. See how it works. And if I need to go a higher wattage, I will. So the first thing we need to do is we need to attach these two pieces together. We use a little connector like this, just standard pipe thread to put in there. And then we're connecting through the back of this one. And then you want to make sure everything's nice and straight. We're going to set it on there and push it back as far as we can so the back of this is up against this thinner piece of MDF. Now we need to screw this to the bottom. We're going to be using brass screws to attach this, and you don't want to use the brass screws right away. You want to bring in some regular screws first in order to set the threads. That way you don't strip out the head of your brass screw trying to screw it in, because it's a very soft metal and it's very easy to strip out. Now on the back of this, these are number 10, And we're going to go into some MDF, so we're going to consider that softwood. So this would be a 3/32 inch drill bit. So I have my drill with the 3/32 drill bit. Start with this one back here. Just kind of get in here. Just gonna, I'm not gonna go too deep. Just mark it here. You can see we're right there. So now we're going to use a normal nickel-plated screw to get the threads set in the MDF. Now I want to plug up these holes so nothing gets in there. Power cord is going to come through this opening right here, so we're going to put a way of sealing the wire so it's less likely to be pulled out and also prevents things from getting inside. That comes off, and there's a little black rubber piece in there as well that will wrap around the cord. So this is just your standard electronics type power cord. I got this one at a garage sale for like $1 or something like that. We don't need the end, so we can cut that off. We are going to need those wires that are in there, the white, black, and green wires. So before we forget, we should probably put on the nut for that wire connector as well as the black rubber piece here. That way we don't have to worry about it later. This wire is going to have to go all the way from the back all the way up to the plug up front. So I'm going to need some length there in order to get all the way through. I think we can safely cut there. And when you're doing this, you got to be careful not to cut through the insulation of the wires underneath, otherwise you got to go get another cord. The best thing to do is just put a little mark in it, bend it back so you can see, putting some tension on it, and you run the knife blade over that mark. Just make it a little bigger until you can see the wire underneath. There happens to be a white wire down there. Now I'm going to bend it kind of on the side over here. Same thing this way. Just work your way around slowly and carefully so that way you don't damage the wires that are in there. And now it's completely apart. Alright, before we put this in, we're going to put a wire tie on there because this rubber grommet is a little loose. And once we screw in the other part of the wire connector here, that wire is not going to come out, so we don't have to worry about it getting pulled out on us. So the white and the green wires are going to go all the way through. And the black one's going to hang out here because this is going to attach to the light bulb base. It's going to connect to one side and then the other and then continue on to the plug. This is going to be what's going to stop the high current from going in to whatever we're working on. So we're going to give ourselves a little room here. Cut that in half. So now you've got extra length of black wire here. So now we need to strip the wire, and we're going to use a wire stripper to do that. We're going to use this wire to figure out what size we need. So I'm putting it into that second, let's see. Putting it in that second hole there. You can kind of see where it's coming out there. As you extend it out, that didn't quite do it. That means it's got to go in the smaller hole. All the way at the far end, all the way over here on this side. You just squeeze it, it pops off. Got nice naked wire right there. Let's see. That's not enough. So, but now we know what size to use. That should give us enough wire. And then we're going to do the same thing with this little wire here. So we just pick a side. We're going to go with the brass side here. Unscrew that. Now to screw it in, it's got to go around this way. So we're going to want our wire to kind of roll over that way. We don't want to strip the hole here, so don't go too tight, but you want it so it's not going to come off. And that's pretty tight there. And then we take that wire that we cut off earlier, we're going to attach it to this side of the base. So now we're going to be screwing this way, so we want our wire to come around this way. And there we go. Now we push this little bit of the black wire through here as well. It comes out over here. And there we go. That sits on there nice and solid. Now we can attach the wire connector back here. We're going to use these screws to put in there. I forgot to rub and buff these. I'll go back and do that. These just go in like this. Alright, so now we have to strip the other wires. This is the plug I'm going to be using. So just like before, these screws are going to go in this direction. So we want the wire to wrap around in such a way that it winds up as we're screwing it in. Same thing for this way. It goes around this way. So the white one connects, the black one connects to the brass colored ones. The white one connects to the silver ones. And of course the green wire connects to the green screw. Now you can just kind of push those back in there. I guess I made that a little longer than I needed it to be, but better longer than not long enough. And you can see there's all sorts of holes to put it in here. These will go in these little holes, and they're already threaded, so they'll just screw right on in. Finally, we add in the bulb. And then finally, the cage. So how about we go see how it works? So first off, let me apologize for the lighting over here. We're on the other side of the shop. I wanted to be as close to the breaker box as possible. Not that there's going to be any problems, there shouldn't be, but you know, just in case. What I'm going to do is I'm going to plug in the current limiter here. Now nothing should happen. And nothing happened. The light did not turn on. You may have been expecting it to, but it doesn't. So now I can plug something into here. You can see that the light turned on just fine. And I can turn it off. And that light stays off as well. Now, this is a bit more scary. Now attached down here, I've got a cable with two wires that I'm going to touch together. They're bare wires. I'm just going to touch them together after I plug it in here. I'm feeling a bit like Mr. Wizard here. Alright. So the current limiter is plugged into the wall outlet, and this is plugged into the current limiter. Now what I'm going to do is I'm going to touch the black wire to the white wire. Normally that would pop the breaker, but in this case, it just turns on the light. It's a little bit of a spark. So the idea here is that when I'm working on any type of electronic equipment, if this light goes on, I know there's danger. It should protect me, it should limit the amount of current flowing into the device, But its main purpose is to let me know, hey, watch out, unplug this, turn it off, fix whatever's wrong before you play around with it anymore. So if you enjoyed this video and thought it was helpful, give me a thumbs up. If you want to see more videos like this, hit the subscribe button down below. And if you have any friends who are working on electronic projects, maybe share this with them so they can protect themselves. All right? Have a good one. See you in the next one. Bye. Ugh.